2, 1.
When we look up at the night sky, we're peering into a vast cosmic ocean with stars shining like distant beacons. But what if I told you that even the closest star beyond our sun is unimaginably far away? Today, we'll explore just how long it would take to reach Proxima Centauri, our nearest stellar neighbor. Let's start with Proxima Centauri. It's a red dwarf star located 4.24 light-years from Earth. While it's the closest star to us, it's still over 40 trillion kilometers away. To give you a sense of scale, that's roughly 271,000 times the distance from Earth to the Sun. So when we think about traveling to another star, we're dealing with distances that challenge the limits of our technology and imagination. But what does 4.24 light-years actually mean? A light-year is the distance light can travel in 1 year. Light, the fastest thing in the universe, moves at 300,000 kilometers per second, or about 186,000 miles per second. That's so fast it can travel around the Earth 7.5 times in just 1 second. So, in a year, light travels nearly 9.46 trillion kilometers, or around 5.88 trillion miles. And Proxima Centauri is 4.24 of these light years away. Even with our fastest spacecraft, we are crawling compared to the speed of light. Let's take a look at the technology we currently have. Voyager 1, the furthest human-made object from Earth, is traveling at about 17 kilometers per second. That's over 38,000 miles per hour. Pretty fast, right? But even at that speed, it would take Voyager 1 around 73,000 years to reach Proxima Centauri. That's older than human civilization itself. New Horizons, which gave us incredible images of Pluto, travels even faster, about 58,000 kilometers per hour. But even then it would take 78,000 years to get to Proxima Centauri. These spacecraft are remarkable achievements, but they aren't anywhere near fast enough for interstellar travel. So what's next? If we're going to reach another star in a human lifetime, we need to go much faster. One promising idea is ion propulsion. This technology uses electrically charged particles to create thrust, and it's extremely efficient. NASA's Dawn mission, for example, used ion propulsion to explore 2 massive asteroids, Vesta and Ceres. While ion propulsion could theoretically keep pushing a spacecraft for years, it's still relatively slow. We're talking about speeds of tens of kilometers per second. Not enough to make interstellar journeys feasible yet. But there are other innovative ideas on the horizon. One of the most exciting is the Breakthrough Starshot project. This ambitious initiative aims to send tiny, lightweight spacecraft to Proxima Centauri using solar sails propelled by powerful Earth-based lasers. The goal is to push these craft to 20% of the speed of light, an astonishing 60,000 kilometers per second. At that speed, these miniature spacecraft could reach Proxima Centauri in just over 20 years. Of course, there are challenges to overcome, like how to steer them and how they'll send data back to Earth. But the project shows that with the right technology, interstellar travel may be within our reach, at least for robotic missions. If we're talking about even greater speeds, we have to dive into the realm of science fiction. Or is it? The idea of a warp drive, made famous by Star Trek, involves bending or warping space around a ship. Instead of moving the ship faster than light, a warp drive would move space itself, allowing the spacecraft to travel vast distances in a much shorter time. While this concept comes from Einstein's theory of general relativity, it's still just that, a concept. Scientists have proposed ways we might create a warp drive, but we're a long way from making it happen. The energy requirements are astronomical, literally. For now, it remains a distant dream. Even if we could solve the problem of speed, there are other challenges. Space is dangerous. Cosmic radiation, micrometeoroids, and the sheer isolation of a decades-long journey could be catastrophic for both humans and spacecraft. Then there's the issue of resources. How do you fuel a spacecraft for a trip that could last decades or centuries? So, how long would it take to reach the nearest star? With today's technology, it would take tens of thousands of years, far beyond any human lifetime. But the future holds exciting possibilities. From solar sails to warp drives, we're constantly pushing the boundaries of what's possible. While interstellar travel remains one of humanity's greatest challenges, it's also one of our greatest dreams. For now, humanity's reach extends to the planets and moons of our own solar system. We're sending probes to Mars, landing on asteroids, and planning missions to Europa, Saturn's icy moon. But beyond our solar system lies the real frontier, an infinite sea of stars, each with its own story to tell. Imagine what we might find out there. Could there be planets like Earth orbiting distant suns? Could there be life, perhaps even civilizations, waiting to be discovered? Or will we find the cosmos to be eerily quiet, a vast expanse of stars without a whisper of life? The journey to the stars is one of the greatest challenges humanity has ever faced. It will take innovation, determination, and perhaps a little bit of luck. But one day, we might finally take that leap. The stars aren't just out there for us to look at. They're waiting for us to explore. What do you think? Will we ever reach another star in our lifetime? And what will we find when we get there? The answers are still out there, just beyond our reach, for now. If these questions intrigue you, if you want to be part of humanity's journey into the unknown, make sure to like this video, subscribe to the channel, and hit the bell to stay updated. Together, we'll keep exploring the mysteries of the universe, one star at a time.